And so this topic they have us predicting bond polarity. So polarity is describing how the electron distribution is around these two bonded atoms, meaning how the electrons are being shared. Are they being shared evenly, distributed equally, or are they spending more of their time around one atom or the other? So what we have here is we have a chemical bond colored in red, and we need to decide whether the bond is polar or not. So if we look at this first molecule that we have here, got a chlorine atom and a fluorine atom. Well, what do I know about chlorine and fluorine in regards to their electronegativity? What are their electronegativities? Well, I know that fluorine is the most electronegative element on the periodic table. Chlorine isn't too far behind it, but chlorine is still less electronegative. So what that means is, in this bond right here, and in single bonds, we are sharing two electrons. This represents an electron pair. Okay, so this is a covalent bond, but it is going to be a polar covalent bond because fluorine is more electronegative than chlorine, meaning it has a greater attraction for these electrons that are being shared between the two than chlorine does. So the electrons are going to be pulled more towards the fluorine atom, shifting the electron density in that direction. Now, this doesn't mean that the electrons are pulled all the way to the fluorine atom because fluorine isn't that much more electronegative than chlorine. So the difference in the electronegativities between the two atoms has to be somewhere around 2 in order for that to happen. If you look at a periodic table that has electronegativity values listed, you will see that if you take the difference between the electronegativity of fluorine, which is something around 4, and subtract it from the subtract the electronegativity of chlorine from that, which is about 3, you only have a difference of 1, which isn't enough for that electron to be completely pulled away and lost to fluorine. So if you look on page 379 of the textbook, you can see the periodic table is showing the relative electronegativities of elements. All right, so to answer this, well, the highlighted bond is polar in this case because one atom is more electronegative than the other. Right here, this will be our answer, and the more negative atom is fluorine because it is more electronegative. The negatively charged electrons, or electrons, are negatively charged particles. And so because the negatively charged electrons being shared here are spending more time around the fluorine because it has a greater pull on those electrons, it is more negative because electrons are negatively charged. For those who are looking for more in-depth explanation of bond polarity, typically what you're looking at is if the difference, so this triangle symbol there, this stands for delta and it means difference. If the difference in the electronegativities of two atoms in a bond is greater than 2 or somewhere around 2, somewhere around there, generally consider that an ionic bond. And in an ionic bond, well, the electrons are completely lost or gained, ionized. Okay? If the difference in electronegativity is less than 2, not that strong, but at least greater than 0.5, then there we are. We have some type of polar bond. And if the difference in electronegativity is less than 0.05, generally consider that a nonpolar bond. So let's look at the second set here in this topic. We have two bromine atoms, and the bond that we're investigating to see whether it would be polar or not is here in red. So there's a single bond between these two bromine atoms. So In order to predict whether this bond, the polarity of this bond we need to ask ourselves, well, what do I know about the electronegativity of these two atoms in this bond? Well, the electronegativity would be the same. If I check my periodic table on page 379 in the book, or you could Google electronegativities of the elements, you see that bromine has an electronegativity of 2.8. That's the value there. And so because it's the same for both, well, the difference in electronegativity between the two atoms in this bond, 2.8 minus 2.8, that's difference, it would be 0. So the difference in electronegativities would be much less than 0.5, and so this would be a nonpolar bond. So the highlighted bond is nonpolar. All right, let's check the last one here. We have molecular nitrogen. We got two nitrogen atoms bonded together. Now this bond is different. It's not a single bond like the other two, but a 1-2 triple bond. But that's okay, because it's still going to follow the same procedure that we used for the previous two examples. I have one atom here on one side of this triple bond, and I have another atom on the other side of this triple bond. Let's ask ourselves, what are the electronegativities of these two atoms relative to each other? Well, nitrogen has an electronegativity of 3. Well, guess what? We have the same atom on both sides of this bond. They're both nitrogen atoms. And so the difference in electronegativity between these two atoms is going to be 0. And so this is going to be a nonpolar bond.